This video is going to cover question number 1981, B2. Again, I have to look at the equation. I have to think of what could I possibly need. Since I see a spring involved here, I'm wondering if I might need my spring equation. And the reason I'm thinking that is if this is a spring and it has energy and this is asking for speed, I might be able to tie these together somehow through conservation of energy. Sometimes you need to read through the problem to find some key words to identify to see what we are talking about or what they're asking about. And in question A, I see them asking about work. And I see up above, I see some speed, and I see several masses. And so I need to think about how to tie those together. One thing we know about work is force times distance. However, in this problem, we don't really know any forces and we don't really know any distances, so even though that is an equation, it's not very much help. The other thing I know about work is the definition of work is the change in energy, and so I think that might be a better way to go. This is a problem that you could think of with an LOL chart. I'm going to just jump straight to what's going on, and that is the work is the change in energy. And so the work is my final energy minus my initial energy. And from that point, all I really need to do is plug in my numbers. The mass that we're talking about is the 3 kilogram mass. And the 3 kilogram mass has a velocity of 10 meters per second. Because in this portion of the problem, the 1 kilogram mass is just sitting there. It's not doing anything other than just being something to push off of, and it's held in place. So it's not doing anything. So really the 3 kilogram is the only one that I need. I need my square here. So I'm going to work out this problem. I'm going to square that, and I get a total of 150 joules. So I compressed the spring. I gave it 150 joules of work. That work can then be used and converted in other types of conservation of energy. So let's go on to the next problem. The difference in part B is this time both masses are released and each moves off separately at unknown speeds. And so what we have is we have this spring, and it's going to send both of them off in their own direction. And so in other words, this spring, which we just gave 150 joules of energy to, we just compressed it so that it has that much energy. It is now going to separate that energy, is going to give some to the first mass, and it's going to give some of that to the second mass. And so my spring potential is 150 joules. Because that's the work I put into it. I put in 150 joules, and it now has stored in it 150 joules of energy. And so my kinetic energies is going to be 1/2 mv squared for each one. And my first mass, I'm going to give that as the 1 kilogram mass. And so when I plug in my information, this is what I get. At this point, I'm kind of stuck. And the reason I'm stuck is I have two different variables, two different velocities, and I can't do anything if I only have one equation with two different variables. And so I need to figure out how are these two variables related. It probably will make sense to you logically that if I go here and I know that these are going to go off in different directions, isn't the one that is 1 kilogram, isn't it going to have three times as much velocity as this one? Because they're going to have momentum is going to be conserved. And so the velocity of this one, if I call this V2, then the velocity of this one is going to be 3 times V2. Or you could say if this one is V1, then this one is going to go 1/3 the velocity of V1. So I need to come down here and plug those in. I don't want to deal with fractions just because they're a mess. And so rather than dealing with fractions, I'm going to change my V1, I'm going to change that to a 3V2. Now the other thing to notice is they're going in different directions, right? This one, the 3 kilogram is going in the positive direction. The 1 kilogram is going in the negative direction. So I might want to put a negative here. Now, as it turns out, I don't really need that negative because it ends up getting squared off anyway. But I do have it there just because it might be, you know, it's something you should pay attention to. They're going in different directions, so let's keep that in mind. So I'm just going to go through and solve this. This becomes 4.5. This becomes 1.5. I now have like terms, and so I can add those up to 6v squared. I then can just divide, and I get 25 joules. I'm going to take the square root of both of those, and so I have 5 joules. I had 5 joules. I'm not going to go into the units, but when I take the square root of this, I need to have velocity. And so my velocity is going to be 5 meters per second. We could go through and go back in the units of joules, but let's just accept that velocity is going to be 5 meters per second. The question was to find the velocity of each one, and I kind of dropped off my subscript here. This was supposed to be the second velocity. So this is the second one, is going 5 meters per second. Well, again, back to that 3-to-1 ratio. If this one is going 5 meters per second, then isn't this one going to be going 15 meters per second?